Okay, right. It says that the ABCD is a cyclic quadrilateral. AE is the tangent. Okay, lovely. CDE is a straight line. Never happened. It was a curvy line. And angle CAD is 32, which is over here. And angle ABD is 40. Work out the size of angle AED, which is the X. Okay. You got to work out this angle here. You must show your working. Give reasons for any angles you work out. Okay, are we happy with that? So let's start working out the questions. What are we going to do, folks? What do we know straight away? What can we start filling in? If we know, okay, we know this is 32 here. If you know this is 32, what else is 32?
That one.
Okay, and what would be the reason for that? We would say it is angles standing on the same arc of a circle are equals. That's 32. That's lovely. Okay, what else? Right. Can somebody spot it a Z flick?
Yeah.
Which is the opposite segment theorem.
B to C, C to A.
Okay, let's have a look at that. Let's make that nice and beautiful. Okay, the blue. Right, let's quickly use a line. Okay. So here's you have from there to there.
Yeah, B to C.
From here to here. From here to here. And from here to here. Is that what you spotted? Junaid, well done. Excellent. I couldn't do it better myself. Junaid has spotted here. This is called alternate. Okay, segment theory. So that's 40. Let's get a brush. And this will also be 40. Okay. Which one be 40? Yeah. Get there. Now, if this one's 40, then this angle will also be 40. Now, why will that one be 40?
Because alternate angles are equal. They're on the same arc, aren't they?
Okay, are we going to say for that question that angles in the same arc are equal?
Yeah. You could say what I said.
Okay, right. So we got that's 40, that's 40. Now, if we know that this is 40 and this is, what's this angle here? This one? 72. Can we work at X now?
Yeah.
Yes, we can. Okay, somebody give me the value of X. So X is going to be what? 180 minus the 40 minus, is it 72?
Yes.
Minus 72.
It's going to be 68. What does that say? 72?
Yeah, 72. Is equal to, what was the final answer?
68.
So we've got quite a bit of explaining to do here. Okay, so what did we say? We said, what? We said angle, this spotted by Junaid, angle DAE is equal to 40 degrees. What's that? 40 degrees. Why is that? The reason is angle subtended by an arc.
Are the same.
Angles subtended by an arc in the same segment of a circle okay, isn't it supposed to be in the opposite segment?
Yeah.
Right. So angle subtended okay between angles. Let's just go a little bit back a bit. I think it's changed a little bit already. Okay, angle subtended between a tangent and a chord equals angle in the opposite segment. Okay, that's the first bit.
What does that say? In the opposite?
Opposite segment, sorry. Opposite segment. Okay, so we explain where the 40 came from. What else did we say? So then we worked out also that angle A, what was it? ACD. No, that's not even. The last line says equals the angle in the opposite segment. Angle subtended between a tangent and a chord equals the angle in the opposite segment. Okay, now let's explain this 40 here. So this 40 is key to the question. Explain that now. So we're going to say now for that one, angle ACD is equal to 40 degrees. Okay, now why is angle ACD equal to 40 degrees? What do we say for that one?
Is it angle between a tangent and chord equals the opposite angle?
No.
You said the.
Or is it angle standing on the same arc of a circle of? Yeah, that's it, isn't it?
Yeah.
That's the one. Can I find my pen? So angles standing on the same arc. Come on, ladies, copy this down. On the same arc of a circle. Okay, where's the arc? The arc is actually here. There you go. Okay, so we explain where the 40 came from. Now, here comes the last part now. The last part, we have to explain where this, about the triangle. Yeah? So what did we say about the triangle? You said in triangle, what was x again? X was what? 68. Okay, so let's label that first. Let's write down there. So angle, or is it AED? Angle AED is equal to 68 degrees. Why is it 68 degrees? So we can say angle sum of a triangle. Now the triangle in question is triangle ACE is equal to 180. So let's do the maths now. What did we do? We said x is equal to 180 degrees minus 40 at the top, 40 on the bottom, and minus 32, which gave us then 68. And that will give us the full mark for that particular question.
So I can't see.
Got it done, yeah? Small, we got that? Are we happy? Yeah. Question number 11. Question number 11, W. So we have a cyclic quadrilateral. Here's W, X, Y, Z cyclic quadrilateral. Okay. Now, write down the size of angle XWZ. XWZ is there.
Isn't it 50? So x and y lines are parallel again.
Okay, that we gotta work the angle out, okay? Now, what do we know?
That x to y, y to z are parallel.
Okay, so these ones they're not parallel, they're equal in size. Okay? Right. If this is 130 and this is a symmetrical, okay, right. Now we can work out from here. If you know 130 here, what else can we work out? Okay, hang on a second. Is this easy? I mean, can't we just grab this, for example? Can't we say the opposite angles of a cyclic quadrilateral is equal to 180? Add up to, yeah? So that one's equal to, what is it? 50 degrees. And the reason is, so we say, let's find opposite angles. Opposite angles of a cyclic quadrilateral add up to 180. So therefore the calculation will be what? Will be 180 minus 130 is equal to 50. And that will give you the angle that we are trying to find in that particular instance. Okay, that's done. So what do we say? This angle here is 50. Okay, are we happy with that now? First one, the last question, folks. Then we need time for us to go as well. Okay.
The next one, 100.
Okay, hang on a second. Whoa. Now, because we know this is 50, we can now work out this one, which is
100.
100. Now, what else? What do we actually work out? So work out angle OZ, OZY, which is which one? This one. Now, that's if you know that these two, OZY is the same as this angle here, isn't it?
Yeah.
Because it's the symmetry of the shape. Because it's these two lines are, these two are radii, and these two are also equal over here.
Oh, 50.
Okay, what will I give you then?
It's 65.
Correct.
Yeah.
But let's do the maths now. What do we say for how do we get the 100? What do we do for that? What do we say? What was the rule for that one then? Let's try that. So we start off with angle XOZ. XOZ is equal to 100 degrees. It's equal to 100 degrees because so the angle which an arc subtends at the center of a circle is twice that. Yeah. It's twice that which is subtends. At the circumference. So that's our first explanation. Then what do we say next?
And then 130 divided by 2 is 68. 65.
Okay, all right. Let's change color for that one.
65.
Next part. Angle. Oh, I didn't ask for that one. Angle. Which is angle going to work out? OZY.
Yeah.
OZY is equal to angle OXY. Okay. Are we happy with that? Okay, and we say the angles in a quadrilateral add up to 360. So what's the calculation that we do here? We do 360 degrees minus 100 degrees minus 130 degrees and then divide it all by 2. Will give us the answer of
65. Can't you just do 130 divided by 2? That's what I know for base 65 is that.